I'm gonna grab yours. It's okay if they're not in order. I'm gonna reorder them. All right, team. So, thank you. All right. So, organic people. Organic chemistry is also known as carbon chemistry. Carbon is a really good building block to life, which is why it is so essential and it's an own branch of chemistry.
Ano pa? Sirain.
Yeah, notes.
Or buka ko sa iyo. Para lang sabihin.
Right, you guys ready? I'm giving some notes. Okay. So, organic chemistry is all based off of carbon chemistry. Carbon is a very special molecule because it can form the maximum amount of bonds possible. So when we look at a periodic table, all right, let's do, for example, nitrogen. So if I do nitrogen and I draw the atomic structure of nitrogen, which has the atomic number of 7 and the atomic mass of 14. So when I go draw nitrogen, in the nucleus, it has 7 protons and it has 7 neutrons. So remember, as a refresher, protons are positively charged, neutrons are neutral. We need to have both in there because positive charges are like charges and they will repel. It'll make a very unstable atom. Are we okay with that so far? This should hopefully be a refresher. So the neutrons are there to act like glue. Those two things add together to make the atomic mass, which is 14. The atomic number is related to the unique number of protons, which is 7. Are we okay with that? This should hopefully be a refresher. Do you need me to write anything down? Yes, please. All right. Atomic number is referring to how many protons or electrons. This is unique to the element. So right now I'm drawing nitrogen, and with nitrogen I can see that there's 7 protons and 7 neutrons. So atomic number for this guy is 7, atomic mass for this guy is 14. Are we okay with that? I'll draw it on the side. So we're looking at nitrogen on the periodic table, 7, 14. All right. What this also tells me is how many electrons are in there as well. Now, just as a reminder, electrons are negative and are in the shell. The first shell can have 2. Second shell can have up to 8. Currently, I have used up 2 out of my 7, so I should have 5 here. 1, 2, 3, 4, 5. Are we okay with that? We good? Oh, you're not on this one. You're fine. I might switch over to the FET so you guys can see it more visually. Can I swap it over real quick? You guys okay? Swap it? Okay. Just want to show you what I mean. So I'm just going to go to FET real quick. That's okay. You're hiccuping. All right, let's just build my atom. That one? I'll do symbols. Actually, no, we'll do this one. All right. So let's say I was building my nitrogen. So I've added one. So you see how you have one proton in the nucleus? That's hydrogen. You see how it's an ion because it's positively charged? Because I have no electrons to balance the positive charge. So if I add an electron, now I have a neutral atom because I have the same number of protons and electrons. We good? All right, so that's what it's looking like. Mass is 1, charge is 0. If I was to look at the symbol, and I did the exact same thing, it is hydrogen. You see how that is, I think the top one's referring, let's see what happens. All right, yeah. Top one is referring to atomic mass, bottom one's referring to atomic number. Are we good? And then this over here is referring to charge. If I add another proton, I now have changed the element. So elements are specific to the number of protons in there. So if I add a proton in here, I now have helium. If I add another proton in here, I now have lithium. I'm going down the periodic table. So I first had hydrogen, I add a proton, now I have 2, that's helium. I add another one, I now have lithium. Are we okay with that concept? All right, now we can see when we're looking at this is really unstable because they're all positive charges and like charges repel. So in order for me to make it more neutral, I am going to be adding neutrons. Neutrons are neutral. You see how I added it? It doesn't change the charge over here. So I'm adding a couple more. Now it's stable. And we see how this 3 is adding up the 3 protons and the 3 neutrons. Oh, sorry, protons and neutrons, yeah. Now we see how this is charged, right? So the way I fix the charge, because right now I have an ion and I want an atom, so I need to add the same number of electrons. You see how that's neutral now? 3 protons, 3 electrons. Are we good? All right, let's go up to nitrogen. So nitrogen was 7. So at carbon, that's nitrogen. Let me add some more neutrons so that way it's not screaming at me. There we go. So, and let's add our electrons. So there should be 5 electrons, or sorry, 7 electrons and 7 protons. You see how that's stable? All right, so this is a neutral atom. However, stability-wise, when it comes to atoms, they want to have a full shell. So the first shell can hold 2, the second shell can hold 8, the third shell can hold 8, and the last shell that we talk about can hold 2. That's up to calcium, because that's 20. 2, 8, 8, 2 adds up to 20. So this rule only works up to calcium. If we go beyond calcium, you are doing level 3 chemistry now. So don't stress. Are we okay with that so far? So for nitrogen to get its full shell, it needs 3 more electrons, which is forming an ion, like that. Okay? -3 now. Are we good? All right, let's go back to the other PhET stuff because I want to show you guys molecules. Build a nucleus. Its molecule polarity, atomic mass and shape. I think probably that guy will show me what I want to show. Actually, let's go real molecules. All right. Actually, we'll do boron. We duplicate this and we can look at boron as well. No, we want to go back. Okay. So something to keep in mind when we are designing our atoms. Let me design boron for you so you can see what that looks like. So boron on the periodic table, or do stability as well. So boron is over here. It is number 5. So 1, 2, 3, 4, 5. We got boron. 1, 2. We're going to add these guys until it's stable. You're still not stable. There we go. Now it's happy. And then I want to add the electrons. So that's 1, 2, 3, 4, 5. All right. This doesn't probably prove my pro very well. Never mind, that's a bad example. But sulfur. No, sulfur's bad. Never mind, that's a bad example. Alrighty, let me backtrack. Okay, I'm gonna make carbon. Okay. Okay. If it's unstable, then it will go through chemical reactions to become stable. Yeah. All right, let's go back here. So when we are talking about nitrogen, we can see that it has 7 protons, 7 neutrons, 7 electrons. Now, in order for it to get stable, we have 2 options. With nitrogen, what it can do is it can gain electrons and become an ion. So it gains 1, 2, 3. And that's one way it can become a stable ion. In organic chemistry, however, we are thinking about compounds. So those are things that have shared, I should say, covalent compounds. Those are things that share electrons. So for example, if I was thinking about hydrogen, so this is hydrogen over here. And that is nitrogen. Now so one option is we form ions. The second option is we form covalent molecules. So in this case, with a covalent molecule, things are sharing the electrons to fill their outer shell. So there's some overlap in their shells. So in this case, a hydrogen comes along to the nitrogen, it shares its 1 electron, and then nitrogen will share one of its electrons, so that way hydrogen now has 2 electrons in its first shell and it's nice and stable. Are you okay with that so far? So, again, this guy over here is another hydrogen, it will share. So we get another hydrogen here, and then this guy over here is another hydrogen, it's sharing as well. So what this means is that nitrogen can form 3 bonds. Carbon's very special because carbon can form the maximum amount of bonds, which is 4. So when we look at the carbon atom over here, you see how it has 1, 2, 3, 4 things in its outer shell. So we got 2 options if it was going to form an ion. It can lose 4 or it can gain 4. But what's more likely for carbon to do is it's just going to share, which is like this guy over here. That's not a good example. All right? So carbon has this unique ability that it can have 4 bonds. And that's because of its grouping over here. So that's carbon over there. That is why so much of life, or sorry, I should say all of life, is made up of carbon. Carbon is a great building block because it can maximize its number of bonds. It can do 4 bonds. Everybody else can only do different numbers. So if we're going to nitrogen, nitrogen can only have a maximum of 3 bonds. So it's not as useful as a building block. Does that make sense? All right, cool. Let me backtrack to this guy. So, organic chemistry is all about carbon chemistry because we can see that organic molecules can make these nice little blocks and different kind of components. The first way we organize organic stuff is by number. So this is 1, 2, 3, 4. This is 1, 2, 3. This one is 1, 2, 3. 1, 2, 3, 4. Do we see how we're grouping it there? So the first way I group organic molecules is by number. The other way you can group it is by functional groups. So that is unique carbon features. So when we're looking at that, we are looking at these guys over here. There are different groupings, and these will then give it different properties. So for example, the first one you guys are going to need to know at level 2 is alkanes. Alkanes are just carbon hydrogen, nothing else. The next one we're going to be covering is alkenes, which have a double bond, at least 1 double bond. The next one we're going to be covering, don't worry, we're going to have a lesson on each one basically. is alkynes. That's a carbon with a triple bond. The next one you need to know is alcohol. So that's a carbon chain with an OH. So OH is oxygen and hydrogen. It's watching our time. All right. You could also do halogens. When we have it annotated as an X, halogens referring to things in group 17. So these guys, fluorine, chlorine, bromine, iodide.
Ooh.
We won't do that one this year. You will do this one this year, which is carboxylic acid. This one is similar to this one. The thing that makes this guy different from that guy is that it also has a double bonded oxygen to it. C double bond O. So just be mindful that those things are slightly different to each other. The other one, and I think the last one you guys are going to be doing is the amines, which is the nitrogen, NH. So those are the ones we are covering at level 2. This one, amines, carboxylic acids, alcohols, haloalkanes, alkynes, alkenes, alkanes. All right, we'll do some more work on this on Thursday, but that's kind of the rough drop in the water kind of thing. All right, can you guys please group together your little cards so I can keep them for next year? I will get a paper clip. Yep. It's a nice little introduction activity.